this is it now with the other part of the system. So there is an Arduino Nano here. So the communication between this microcontroller and this one. So this connects to the internet and send the density values based on how many there are more cars concentrated on one side. So it sends those values to this, then this adjusts the timing of each of the road. So the display of the panel may not be that clear. I think the display is dim because of powering it with my computer. Let me use a DC jack. So but basically just need to do some tweaks to the program. So there are two firmwares that is controlling this. This is the one for the wired, so you can see clients and Wi-Fi. Those are for the internet connectivity. Button classes. Okay, this is an IoT class to filter out the signals in the road. You do hourly reset, so it connects to an NTP time server. So make sure the time is synchronized with the server time. Update the counts, update density. Okay, this one too. Make sure that two of them are in sync, and once the value changes, we wait for another time. So it resets the waiting time. The update count is for each of the roads. Communication. This is the one that it reads value from the other microcontroller. So it deserializes the JSON coming in and updates the states from there. This one updates all the roads, Wi-Fi clients. I think this sends it sends value to the other one on the density. That's at the refresh rate of 1 Hz, 1 time per second. So it adds it to the JSON and then deserialize it and send it. Then this is the one that connects to the server. So this is the server URL to push data at a specific format. Then this is the one for the control, the one that is controlling the displays. So each of them have their timing. These are the default timing before density can affect it. This is go-index. So at what index of each of the road can I change so that to elongate the time or reduce the time for a specific row. Then the I2C address for each of the display, the sequence, go ready, stop, blah blah blah. This make sure this is the one that gets value. So once it's find out that it starts with this character because I use that same character here, so as to distinguish it from other things sent to the microcontroller. So it extracts the JSON. If not, it read other data and display it to the computer or send it through the USB cable in case it's connected, so I can monitor and do debugging. And this other displays I can go through it. So this is the stage of the traffic control project. So this is like the the fourth iteration of me working on a project related to traffic. So the first one was just having 3 roads running. I was just trying to simulate multi-processing on a one core CPU. So it was an 8-bit microcontroller, but I was able to use technique of pooling to have 3 processing occur at the same time on one thread. So in this configuration, I have this microcontroller, an Arduino Nano. This coordinates this aspect of the traffic. So it displays values that's the countdown for each of the roads. This is road 1, road 2, and it also controls the lights. That's the LEDs. So basically these are just normal LEDs with resistor. I solder them on very board. So there's a communication that goes down here. So this 4 wires just to supply power and to communicate with this microcontroller. So this microcontroller is an ESP8266. It connects to the internet via Wi-Fi. As it's connected to the internet, you can see the indicator is blue, so it's turned on. What this microcontroller sends to this is just the state. This road 1 is on go, this road 1 is this road 1 is stop, yellow. So it sends the states, the traffic states, and those numbers are encoded. 0 indicates red, red as stop, ready, 1, go, 2. So and it sends this as JSON, JavaScript object notation. between this. So what this one sends to the ESP, the Arduino Nano, is the density. So basically these also have inputs, 6 inputs from these IR sensors. So they are more like, they are just sensors to tell us the state of each of the road. So if it's triggered, for example, as in this manner, it can detect. So once there's a trigger like this, it's register a count. Also, that's in similarities for each of the road. When I talk about this, it's generalized for all of them. Then once one is activated here, the density is 1, rather than when both of them are empty, the density is 0. So once one is activated, 1, the other one is activated, 2. But when they stay for a longer period of time, it will become 3. So basically, connecting to the internet, there is a backend server that I built with Python, so you can be able to get the traffic info, like you can monitor it. Those values should be updating on this monitor. So let me refresh the page. Alright, so currently I've been able to get it connected. So as you can see, road 1 it's activated for a long period of time. This one too, they are both activated. So as you can see, road 1 and road 2, the densities, this one, the density is very congested. So I think one is already free here. That's why. It also kind of behaves with color. Let me use a different vehicle. Okay. Color also contributes, because if it's a color that absorbs the IRO lights, it will not detect it. So as you can see, also for the states, though I think there's a lag somewhere. For the states, red. It's supposed to change. Alright, so as you can see, road 1 is on go. On the panel, it's go. So maybe I remove this. The density now is 1 on road. Okay, I think it will take some time first. So it has changed now to 1. So these 2 of the roads now are ready to switch. So that's ready. So now this is stop, go. So as you can see here, stop, go. So it works. Then basically, as I move stuff around, do this. Okay, let me count some certain. Don't mind, there will be like some latency, like time before it will actually reflect, maybe due to network and some other processing. So as you can see, the count has become 5. So there's default count of around -2 for each of the road. That's to account for like some noises, but it can basically be removed. It seems that the count has become 8. If I maybe increase the count 1, 2, 3, I should have something. I should have a change. They take time. Alright. Alright, the count is already reflecting. I see I have a count of 5. So if I check here, see that also counts 6. So if I make these roads empty, I should have all the densities empty. Take some time first, but yeah, it's updated now, empty. So you can also change the refresh rate on the panel. That's how many times you want it to update from the server. That's on the client side. So basically, this is the entire project, and it's work pretty well. But in a real implementation, the use of IR sensors are very unstable and impractical. So we use cameras we run computer vision model too, so you can also extract plate number to look at offenders, defaulters, and basically it's really okay. So that's it. Go, stop. So the one has changed, but it didn't log it at the same time. So this one is ready. Stop.